G'day, Unine. Hope you're doing all right after yesterday. I know it was a long test. You probably had a busy week, so today is going to be relatively short. If you get through the work today, you'll have some time to prepare for next week, do a little bit more revision, things like that, if you are able to. Okay, so last lesson we looked at congruency proofs for triangles. We looked at how we set out those proofs. So we start by thinking, okay, which direction am I going to go in? What information do I have? Am I going to go SSS? Am I going to go SAS, AAS, RHS? Okay, having an overview. And then we want to set out 3 lines of reasoning. Okay, so if it's SAS we're going for, we want to show that 2 sides are equal, we want to show that 2 angles are equal, and then we want to show that 2 sides are equal, giving a geometric reason for each step. And once we've done that, we can come up with a therefore statement. Therefore, this triangle is congruent to this triangle, making sure that the order of the vertices that we write it in match. Okay, so you've got equal angles with equal angles for each of those letters. All right, today, we're going to be doing a bit more of that, and we're also going to be using that fact to prove that other angles and sides are equal, okay, because they're corresponding. But then we're going to use that to prove features about shapes that we may already have known, but we're sort of proving it from first principles, okay? And so that's sort of where this topic is going. We're going to use these proofs to show that shapes have particular properties by using congruent triangle proofs. All right, let's jump into this one example and then I'll leave you to it. So we're going to prove that PRS is PRQ. So we'll sort of cut this triangle into 2 smaller triangles, and we want to show that the 2 smaller triangles are congruent. We know that if I have a look at what information I have, I'm told that PR and SQ are perpendicular, okay, which means that PRQ is 90 degrees, but also that PRS is 90 degrees because it's perpendicular. We also have 2 sides that we're told are equal. And then we have this side PR, which is sort of in common with both of the smaller triangles. Both of the smaller triangles use that side in their shape. So we call that a common side. So that means I have a right angle, I have hypotenuse, I have another side. I'm going to go for RHS when I set up my proof. Okay, so I've chosen my path that I'm going to try and prove. R stands for right angle, so I'm going to say that angle PRS equals angle PRQ. Q, which equals 90 degrees, and we're given that information, okay, because we're told they're perpendicular in the question here. So you can see how I've done it. I've just done 2 equal signs, so saying that the angles are equal and they're both 90. That's a shorthand way that you can do that. Now I need to show that the hypotenuse is equal, so PS equals PQ, and we're given that as well. Okay, very easy when you're given the information. You don't have to come up with a more difficult reason. And then finally, PR is common. Okay, so we don't have to say PR is equal to PR. We can just say that PR is common, and that's enough to say that we have equal sides there. Okay, so I've got my R, I've got my H, I've got my S, so I can say therefore. Now I'm going to copy the order that they've written it in the question. Triangle PRS is congruent to triangle PRQ, and my reason is RHS. Okay, I'm allowed to use that abbreviation when talking about congruent triangles. Okay, so I've done part A. I've set out my proof. For part B, I need to show that PSR, so this angle here, is equal to PQR, okay, and this is a relatively straightforward thing, and you'll use this reason a lot once you've done a congruency proof. You'll say corresponding angles in congruent triangles. Okay, corresponding angles in congruent triangles are equal. Okay, in the same way, when we do C, SR equals QR, okay, SR equals QR, Okay, and the reason is corresponding sides. Incongruent triangles. Whoops, screen glitch there. Congruent triangles. And then finally, we need to show that SPR, so the top angle, is equal to QPR, Queen's Park Ranges. So we've got angle SPR is equal to Queen's Park Ranges, and that's corresponding angles. Okay, so it might seem a bit repetitive. Usually you won't have to do 3 of the same thing. And you won't get multiple questions like this in a test usually. So you won't have to be doing this hundreds of times usually. So that's all. Okay, so we've done this, and now finally we need to use this congruency proof. Okay, so it's saying complete the following 2 properties of isosceles triangles which have been proven above. So the angle opposite the equal sides of an isosceles triangle. Okay, so the angles opposite the equal sides, we've shown that they're equal because the reason that we gave was because they were corresponding angles in congruent triangles. Okay, so we can finish this just by saying equal. Okay, we're just completing that the reasoning there, but we've shown that from first principles. For part 2, we've got to show that the line drawn from the vertex of an isosceles triangle and perpendicular to its base, so this line, bisects the angle and the base of the triangle. So this is bisected, okay, because we showed that those 2 angles were true down here in part D. We've also shown that SR and RQ are equal, so that means that's bisected. So it bisects the angle and the base. Both of those are cut in half. That's what bisect means. Okay, so you'll do a bit more of this where you prove properties of shapes using congruent triangles. I hope you enjoy the video and enjoy the weekend when it comes. See you later.